Let's do a little review with doing math on our common logarithms. I know this is very different, so we want to spend a little bit more time here. We learned patterns. We learned that our multiplication is associated with addition. So these two things match up. We learned that our division is associated with subtraction. And then we also learned that our exponents, if I have something in the front of this, we'll make a variable there. Let's say I have x, that it's the same thing as the log of base p of m to the x power. So the front gets moved to an exponent location. All right, let's do a few problems on this, just to review before we go on to the new stuff. The new stuff is mostly calculator use, so it's not going to be hard today. All right, I can't get rid of the logarithms until I combine these two logarithms, because I can only have one log on each side, has to have the same base number to get rid of it. So we know that this is addition, which is the same as multiplication. So I can rewrite it as the log of base 8 of 2 times x is equal to the log of base 8 of 7. Now I can get rid of the logarithms. It's almost like I'm dividing through by the log of 8. So then I have 2x is equal to 7, or x is equal to 7 over 2. Let's do another one. All right, I've got to do what's inside the parentheses first. That is addition, so I know that that's associated with multiplication. This side doesn't change. So I have 5 times the log of base 5 of 4 times 2. Okay, 4 times 2 is 8, so again, now I have the log base 5 of 8, but I bring my 5 that's in the front onto the 8. Notice, well, somehow I changed that. This one should have been a 5. Your logs match up, so it's like dividing by the log, and you get x is equal to 8 to the 5th power. If you wanted to, you could do that out on the calculator to get an actual value for it. Let's do another one. All right, this is subtraction, and remember subtraction is associated with division, so I have a log base 4 of x squared minus x minus 2 over x plus 2 equals 2. I want to factor that if I can, because I might be able to reduce it before I do any math on it. So I have x minus 2 and x plus 1 on the top, giving me an x plus 1 on the bottom. So those two do go away. Now notice I only have a logarithm on one side. So to solve this, I'm going to have to put it in exponential form. So I have 4 to the 2nd power is equal to x minus 2. So 4 to the 2nd power is 16. X minus 2, I'm going to add the 2, so I'm going to get that x is equal to 18. All right, I'm going to put a couple up here for you to try, and then we'll go on to the new stuff. All right, do this one out. do this one out. Do those two, then come back to the video. All right, I know that this is addition, so it's the same as multiplication. So this is the log of base 3 of x times 2 times the log base 3 of 5 times 4. I'm going to multiply the 5 times 4 and carry the 2 to the back. So that's going to give me that. Notice I have a log of base 3 on both sides, so I find out that x is equal to 20 squared, which is the same thing as 400. All right, this one down here, there's not a whole lot I can do here. So the only thing I can do is write it in exponential form. So I have 2 to the first power is equal to x squared plus 3x plus 4. Remember, it's this to this power equals this. I'm going to subtract the 2. So I have x squared plus 3x plus 2. I'm going to do this out. So I have x and 2 and 1. And when I solve this thing, I'm going to get x is equal to negative 2 and x is equal to negative 1. Now we know sometimes there's a problem with a negative, but we have to plug it in and see if it gives me a negative in the parentheses. Negative 2 squared is 4. 4 plus negative 6 is going to give me a negative 2, but negative 2 plus positive 4 gives me a positive 2. So that one works. This one gives me a 1 plus a negative 3, which is going to give me a negative 2 plus a positive 4, which again gives me a positive 2. So that one works. All right, now on to the new stuff. The new stuff is mostly calculator, as I said before. If you pick up your calculator, you'll notice on your calculator that there is a log button. Okay, that log button is right underneath your x squared. The log on your calculator is an understood base 10. So, for example, let's do this by hand and then I'll show you how it works on the calculator. Let's say I have that problem. In order to do that problem, I'm going to go 10 to the x power is equal to 1,000. If I rewrite the 1,000 as a base 10, I quickly find that x is equal to 3. Now, I want you to take your calculator and I want you to go hit the log button. So I'm going the log of 1,000, then punch in 1,000, and then hit enter. And see if you don't get an answer of 3. Okay, so take your calculator, try it out. Log of 1,000, enter, and it gives me a 3. So the log button on your calculator has an understanding that you have a base of 10. For the most part, you're just going to use your calculator to find the logs of certain numbers, and you're going to round it to 4 places after the decimal. So go ahead and try these out on your calculator. All right, when you punch those into your calculator, the log of decimal 0.038 should give you negative 2.4202, and you're rounding to 4 places. This one should give you 0.4150, and this one should give you negative 3.3872. All right, there's another thing that you can do with your calculator and logarithms. And sometimes what happens, and I'm going to erase, let's erase the bottom 2. You found this part by using your calculator. Sometimes what they want you to do is they want you to find the antilog of something. A-N-T-I-L-O-G. So if I want to find the antilog of negative 2.4202, what I'm actually looking for is this part. I'm going, what can I take the log of to give me this? Well, this again is calculator use, because if you pick up your calculator, the antilog button is the number, or the little, on my calculator it's blue, above the log. So what I'm going to do is I'm going to do the second button, then I'm going to do the log button, and that's going to give me the 10 to the x power. And what it's saying is, what can I take the logarithm of that's going to give me that as an answer? So if I turn around and I do second, and then I hit the log button, and then I do negative 2.4202. Negative 2.4202. Oops. And hit enter. It should give me that as an answer, 0.0038. So it's almost like a backwards of the log, and it will tell you, find the antilog of this, or find the antilog of that. Now later on, we're going to do problems where you're going to have to figure out whether you're going to use the logarithm or the antilog, but not today. All right, so on your calculator, go ahead and find the antilog of 3.073. Go ahead and punch that in. When you get the answer, it should be 1183. Okay? All right, try a couple more. You're finding the antilog of 0.1790 and negative 2.2790. And again, you're rounding it to 4 places. So go ahead and do those. This one should give you 1.5100, or just 1.51. This one should give you decimal 0038. All right, so you're going to have some homework, not only on doing the math with logarithms, which was like the last video, but you're also going to have homework on this. Now the homework for this is going to be real easy. It's just a matter of punching it into your calculator. So your homework is page 615, 27 through 37 odd. Now that's the old stuff. Okay, this is the new stuff. Page 620, 18 through 29, all. Now in the instructions, it asks you about the mantissa and the characteristic. You don't have to worry about that. All you have to worry about is plugging it into your calculator and getting the answer.